Welcome back, dear students. Today we'll be starting with a new chapter, that is chemical bonding. So first of all, we'll see what does a chemical bond means. Well, as far a chemical bond is concerned, we can say a chemical bond is a force of attraction, of attraction that holds together two or more atoms, ions, or molecules. So a chemical bond is a force of attraction that holds together two or more atoms, ions, or molecules. Now the question comes to our mind, then what's the difference between a force of attraction and a chemical bond? There are a lot of places where you'll see force of attraction between some atoms, ions, or molecules, but they are not practically bonded to each other. Suppose I have got an atom that is X, I have got another atom X. If they are experiencing a force of attraction, then there is a law of chemistry that wherever there is high attraction, there is always lowering of energy. That means some amount of energy will be given out. When there is a force of attraction between two atoms, then due to attraction, their energy will decrease and excess amount of energy will be given out. This energy which is given out is directly proportional to the force of attraction. So higher the attraction, more will be the amount of energy given out. If this energy which is given out is more than 40 kilojoule per mole, then in that case we say that the force of attraction is so very strong that the two atoms are practically bonded to each other. If the given amount of energy is lesser than 40 kilojoule per mole, no doubt the force of attraction is there, but a chemical bond is not formed. So if we say that chemical bond is formed, that means the force of attraction is so high that the energy which is given out is more than 40 kilojoule per mole. So we can say all chemical bonds are force of attraction, but all force of attraction are not chemical bond. Now we know that attraction can be there between a cation and an anion. Suppose I have a cation and I have an anion. There will be attraction between these two ions. So there can be a force of attraction. So if we talk about a cation and an anion, there can be a force of attraction between a cation and anion because they are oppositely charged. So they have a Coulombic force of attraction among them. But a question comes to our mind, how come there is a force of attraction between two neutral atoms, that is, say, X and X? How they experience a force of attraction? If we have got a cation and we have an anion, a force of attraction among them develops, that is quite understood. But how come two neutral atoms, they will have a force of attraction among them? Well, to understand that, we'll look at in a different way. Suppose I have an atom. This is the nucleus of an atom and this is the atom X. I have another atom. This again is atom X. Now we'll observe one thing, that the nucleus of atom X will attract the electrons of another atom X. So these are the attractive forces. Likewise, this nucleus will attract these electrons. They are again the attractive forces. There will be a repulsion between their valence electron. So these are the repulsive forces. And there will be a repulsion between their nucleuses. This again is a repulsive force. So when two neutral atoms, they approaches each other, some new forces they get developed. that is the attractive forces between the nucleus of one and the electrons of another, and repulsive forces between the valence shell of both the atoms and their nucleuses. Now, whenever the attractive forces are more than the repulsive forces, a chemical bond is formed. So when two neutral atoms are approaching, some new forces are developing. If attractive forces are more, then the chemical bond is formed. However, if the repulsive forces are more, then the bond is not formed. We'll see how these attractive and repulsive forces they develop. Now suppose here I am showing you a graph, and the graph is between the potential energy and the distance between the center of the two atoms. This is the distance r. Now suppose this is the energy possessed by both these atoms. Here I have atom X, here again I have atom X. When these two atom X they are coming closer to each other, attractive forces will develop. The nucleus of one will start attracting the electrons of another. So as a result of that, since attraction increases, the energy will decrease. So the graph goes like this. Here you will see that as two atoms they are coming closer to each other, attraction is developing, their energy is decreasing. This energy will reach a minimum value, and beyond means this is the distance where you have got that minimum value of energy. Beyond this distance, if the two atoms they'll come closer, they will start experiencing repulsion among themselves because their valence shell will start repelling. So beyond this distance, if the two atoms they come closer, they'll start experiencing repulsion and their energy will increase. So again, students, what happens when two neutral atoms they come closer to each other? The nucleus of one attracts the electrons of another and vice versa. So attraction develops, and as a result of that, the energy decreases up to a certain extent, up to a particular distance. Beyond that distance, if they come closer, the repulsion among their valence shell develops, and so their energy increases. So this is the graph we have got of potential energy. This distance, as you can see here, this distance between the center of the two nucleuses is known as the bond length. So what is bond length? It is the distance between the center of the two combining atoms where the attraction is maximum and the repulsion is minimum. So at bond length, the energy of the two combining atoms is minimum. So this is what bond length is. Now we have to see how these atoms or why these atoms they combine, why they form chemical bond, how they form chemical bond. Well, for that we will deal with a theory. That theory will tell us why chemical bond they are formed and how they are formed. And that theory is known as the valence bond theory. If I say the valence bond theory, it basically deals with the valence electrons. So according to this theory, the first assumption is only unpaired electrons takes part in a chemical bond. Only unpaired electrons take part in chemical bond. Only the electrons of valence shell takes part in a bond. The electrons are shared or completely transferred during a bond by an atom so as to complete their octet or duplet. So atoms, they combine or they form a bond either by sharing or by transferring electron so as to complete their octet or duplet. So this is what Valence bond theory is. And we'll see some molecules which basically obeys this theory. I'll give you an example of hydrogen, chlorine or oxygen molecule. They are homoatomic molecules. So first we'll see homoatomic molecules. Now suppose I'm talking about hydrogen molecule. If I have a look at the electronic configuration of hydrogen, it is 1s1, which is like this. Another hydrogen that again has got electronic configuration 1s1, but the spin of electron is in opposite direction. So these electrons, they will be shared so as to form a bond. So if I draw structure of that, here I have hydrogen with an unpaired electron, here another hydrogen with another unpaired electron. A bond is formed, duplet of one hydrogen is completed, and likewise duplet of another hydrogen is completed. If we have a look at this molecule, it fulfills all the conditions of valence bond theory. That is, only unpaired electrons take part in chemical bond, only the electrons of valence shell take part in chemical bond. The electrons are shared so as to complete their duplet in this case. Likewise, we'll have a look at another molecule, that is Cl2 molecule. Chlorine. It has 2 electrons in the S. It has 5 electrons in the P. So 1, 2, 3, 4 and 1, 5. Likewise, another chlorine. In its valence shell, it has got 2 electrons in the S, that is 1 and 2. And 5 electrons in the P, that is 1, 2, 3, 4 and 1, 5. In this case, I'll change the spin, because if the spin is same, the electron, they will experience repulsion. The spin has to be different, then only they will experience attraction. So the spin is anti-clockwise. These two unpaired electrons, they will experience attraction, they will form a chemical bond. So if I draw a chlorine atom, that will have electron like 1, 2, 3, 4, 5, 6 and 1, 7. Another chlorine atom, 1, 2, 3, 4, 5, 6 and 1, 7. These unpaired electrons, they are shared. So you will have a single bond between chlorine atom. If you have a look at this like this, the octet of one chlorine is complete and the octet of another chlorine is complete. So again, Cl2 molecule is also fulfilling all the conditions of valence bond theory, that is VBT, that only the unpaired electron is taking part in chemical bonding, only the electron of valence shell is taking part in chemical bonding, the electrons are shared so as to complete the octet of chlorine atoms. Likewise, we can see one more molecule. Now suppose I am talking about oxygen, O2. Oxygen has got 2 electrons in the valence S and oxygen has got 4 electrons in the valence P. So 1, 2, 3, 4. Another oxygen atom I have got that again has got 2 electrons in the valence S and 4 electrons in the valence P. 1, 2, 3, opposite spin you have to draw. So this is opposite spin. Attraction among these two electrons, attraction among these two electrons. So oxygen atoms, they will have double bond. So here if I have got oxygen, these are the paired electron, these are the paired electron, here I have 2 unpaired electron. Another oxygen atom, 2 unpaired electron, paired electron, paired electron. These electrons are shared, so a double bond is formed. If you have a look at this atom like this, its octet is complete. Likewise, the octet of this oxygen atom is also complete. So O2 molecule, in O2 molecule, the oxygen atoms are also obeying valence bond theory. Only the unpaired electrons are taking part in chemical bonding. Only the electrons of valence shell are taking part in chemical bonding. The electrons are shared so as to complete their octet. Now after this, I'll show you some heteroatomic molecule. Two molecules I'll show you that. First I'll show you HCl. HCl, well, you know hydrogen, it is 1s1. Likewise, chlorine in the valence S has got 2 electron, and in the valence P has got 5 electron. 1, 2, 3, 4 and 1, 5. These unpaired electrons, they will be shared so as to form a chemical bond. So here if I draw hydrogen with the unpaired electron, chlorine 1, 2, 3, 4, 5, 6, 7. A bond is formed here. If you have a look at this, the duplet of hydrogen is complete and the octet of chlorine is complete. Dear student, these structure which I am drawing for HCl, for O2, for Cl2, for hydrogen, where I am drawing dots as electron, the dots they are representing electron. They are known as the Lewis dot structure for these molecules. So these are the Lewis dot structures. These are the Lewis dot structures. Another molecule I'll show you is NH3. Now let us have a look at nitrogen, which has got 2 electron in the valence S, so that is 2s2, and 2p3 we have got, that is 1, 2, 3. These 3 unpaired electrons will get shared by 3 hydrogen atoms, 1, 2 and 3. They'll get shared by this. So 1 bond, second bond and third bond. So if I have got nitrogen like this, here are the paired electrons, here is unpaired 1, 2 and 3. And these unpaired electrons, they are shared by 3 hydrogen atoms so as to form 3 bonds, 1 bond, second bond, third bond. If we have a look at nitrogen, the octet of nitrogen is complete in this, and the duplet of hydrogen is also complete. So here you can see this is the NH3 molecule. Dear student, these 2 electrons which are involved in a bond formation, this pair of electron is known as bond pair. And this pair of electron which is not forming any bond is known as the lone pair. So you have bond pair and lone pair. 1 lone pair and 3 bond pair in NH3 molecule. So this is the NH3 molecule. One more molecule we'll see, that is H2O molecule. Oxygen has got 2 electron in the valence S subshell, and it has got 4 electron in the valence P. 1, 2, 3, 4. And they are shared by 2 hydrogens. So here I have 1 hydrogen and here I have another hydrogen. So when they are shared, 2 bonds they are formed. So let us have a look at oxygen atom here. This is oxygen with 1 pair of electron, another pair of electron, 1 unpaired electron, another unpaired electron, hydrogen here, another hydrogen here. When they are shared, these bonds they are formed. If you have a look at hydrogen like this, its duplet is complete. And if you have a look at oxygen, its octet is complete. Again, this pair of electron is bond pair and this pair of electron is lone pair. So here we saw that these molecules, they are satisfying all the assumptions of valence bond theory. That is, only unpaired electrons are taking part in chemical bonding. Only the electrons of valence shell are taking part in chemical bonding. The electrons are shared so as to complete the octet or duplet. Duplet only in case of hydrogen. In rest of the atoms, it is octet. So this is what we have got. Now, some doubts they were arising after this theory. I'll show you those molecules which were doubtful. Their explanation was quite doubtful. But later on, valence bond theory came up with another explanation for that. For example, if I talk about, say, beryllium. The configuration of beryllium is 2s2. That is, it has got 2 electron in the valence s and no electron in the valence p. So it has got 2 paired electron. Likewise, if I talk about boron, it is 2s2, 2p1. That is, in the valence s we have 2 electron. In valence p we have only 1 unpaired electron. Likewise, if I talk about carbon, that is 2s2, 2p2. 2 electron in the valence s and 2 unpaired electron in the valence p. Now, according to BBT, since beryllium does not have any unpaired electron, it should not form any bond, whereas beryllium forms 2 bonds, like in beryllium chloride. Likewise, boron, which has got 1 unpaired electron, should form 1 bond, whereas it forms 3 bonds, like in boron trifluoride. Carbon, which has got 2 unpaired electron, by mistake I have drawn 3, so let us make it 2. So carbon, which has got 2 unpaired electrons, should form 2 bonds, whereas it forms 4 bonds, like in CH4. So how come these elements, they are not obeying valence bond theory? Although they have got lesser number of unpaired electrons, but they are forming more number of bonds. How it is possible? Well, to explain that, valence bond theory gave a concept of excitation. According to this concept, since the electron they are in the same shell, you have 2s2, 2p0. So they are in the same shell. So very easily it happens that an electron from the s jumps to p. Now when one of the electron from s will jump to p, you will have 2 unpaired electrons, one in s and one in p. These 2 unpaired electrons will take part in chemical bonding, and that's why beryllium form 2 bonds. Similarly, in boron, when one of the s electron will jump to p, you will have 3 unpaired electrons. And these 3 unpaired electrons will take part in chemical bonding, so boron form 3 bonds, like in PF3. In methane also, one of the s electron will jump to p. That will lead to the formation of 4 unpaired electrons. 2 unpaired electrons were already there. When one of the s will jump to p, you will have 3 unpaired in p and 1 in s. So total unpaired electron will be 4. And these 4 unpaired electrons will take part in chemical bonding. So this is how it explained the formation of more number of bonds than the number of unpaired electrons. The number of unpaired electrons were lesser, but the number of bonds formed were more. So valence bond theory explained it like this. Well, in that case, another question arises then. Suppose I talk about the structure of beryllium chloride, BeCl2. BeCl2 is a linear molecule. Now, if we have a look at the configuration here, I'll remove this one electron from here. If we have a look at the configuration, that means one of the unpaired electron in beryllium is present in valence s and another unpaired electron is present in valence p. That means out of these 2 bonds, one of the bond is formed by s, another bond is formed by p. The bond, suppose this is formed by s and this is formed by p. If one of the bond is formed by unpaired electron present in s subshell is closer to the nucleus, so one of the bond has to be smaller, and the another one which is formed by p has to be longer. So one of the bond has to be smaller, another one has to be longer. The smaller bonds are stronger, so one of the bond has to be stronger, the another one has to be weaker. Whereas it is observed in beryllium chloride BeCl2 molecule that both these 2 bonds, they are of same length and they are of same strength. Neither they are so small as that of S nor they are so large as that of P. Neither they are so strong as that of S nor they are so weak as that of P. Well, to explain that, valence bond theory gave a concept of hybridization. Hybridization. So according to this concept, these bonds, they are neither purely S nor purely P. They are actually hybrid. They are SP. They have got partially S character and partially P character. So some of their behavior is like S and some of their behavior is like P. Now what is hybridization? And to understand hybridization, we'll be studying about valence shell electron pair repulsion theory. But that we'll be doing in the next lecture. So today what I taught you, a recap of that, what is a chemical bond, how a chemical bond is formed. That is, when two neutral atoms, they come closer to each other, some new forces they develop like attractive and repulsive forces. If attractive forces are more, then the bond is formed. If repulsive forces are more, the bond is not formed. The distance between the center of the two combining atoms, where the attraction is maximum and the repulsion is minimum, that is where the potential energy is minimum, is known as the bond length. After that, we talked about valence bond theory. That is, only unpaired electrons take part in chemical bonding. Only the electrons of valence shell take part in chemical bonding. The electrons are shared or completely transferred in a bond so as to complete their octet or duplet. Then we saw some of the homoatomic molecule like hydrogen, chlorine, oxygen, and some heteroatomic molecule like HCl, NH3 and H2O. After that, we did concept of excitation, that although the number of unpaired electron is lesser, but the number of bond formed is more. How it is possible? We saw that. After that, we talked about hybridization. So what is hybridization and how hybridization affects the shape of the combining, the shape of the molecule? We'll talk about that also in the next lecture. So that's all for today. This is what we were scheduled for today. In the next class, hybridization will be taking, so that is quite an important topic. So please don't miss it, and do subscribe this channel so as to get lectures on time. Thank you very much.